Alright, in order to watch this video, you should have done the pre-notes video talking about adjacent and form a linear pair or non-adjacent, and you should have looked at complementary and supplementary angles. So before you move on to this, I would take a look at that. Okay, so let's take a look at these. It says, tell whether the angles are only adjacent, and form a linear pair. So the things you're looking for are if the two angles it's talking about have a common vertex, have a common side, and if they are opposite rays. Okay, so let's take a look at AEB and BED. Okay, so AEB is this guy outlined in black, and BED is red. Alright, we can see that they have a common vertex, we can see that they have a common side, and we see that they form an opposite ray. So we know these guys are adjacent and form a linear pair. Okay, so they're adjacent and they form a linear pair. Okay, so that's example 1. I'm going to go ahead and erase all my markings here. Okay, let's take a look at example 2. AEB and BEC. Okay, so AEB we'll outline in blue, and we'll put BEC in red. Okay, so we see that they have a common vertex, we see that they have a common side, but they do not form an opposite ray, so we know that they are just adjacent. Okay, I apologize for my handwriting. Okay, let's move on to the last one. Okay, let's do angle DEC. DEC is in red. Oops. Sorry, it's in red. And AEB we'll put in blue. Okay, so this time they have a common vertex, but they don't have a common side, so they are not adjacent angles. So this one would be not adjacent. Okay, so you just need to know those 3 different things, whether they have a common vertex, common side, and they have to form an opposite ray. Okay, so let's look at these guys down here. We'll look at example 4. Alright, let's look at example number 4, angles 5 and angle 6. Okay, so angle 5 is this guy, and angle 6 is this guy. Okay? Alright, so if you take a look, you'll see that angle 5 and angle 6 have the same vertex. They share a side, and they also form an opposite ray. So we know this is one of those that form an adjacent. It is adjacent, and it also forms a linear pair. Okay, so it's an adjacent and it forms a linear pair. I apologize for the handwriting. Okay, so let's go ahead and take a look. Alright, I would like you to take a look at example 5 and example 6. Check whether they have a common vertex, a common side, and an opposite ray. And then decide if it's adjacent and forms a linear pair, or it's non-adjacent. Okay, we're going to move on to example 7. We want to find the complement of angle F. Okay, remember the complement means that it adds up to 90 degrees. Okay, so we're going to have the formula 90 minus x to represent complementary, and we're going to go ahead and plug in our value in this one, which is 59. Okay, so we have 90 minus 59, and that gives us 31 degrees, which we would know to be the complement of 59 degrees. Okay, fairly straightforward. Example number 8, it wants us to find the supplement of angle G. Okay, so this one requires a little bit of work. The formula is going to be 180 minus x. Okay, and we're going to go ahead and plug in what x is over an angle G, which is 7x plus 10. So we have 180, and we're going to subtract 7x plus 10. And if we go ahead and distribute that, you get 180 minus 7x minus 10, and if we combine like terms, you get 170 minus 7x. So the complement to 7x plus 10, or the supplement to 7x plus 10 would be 170 minus 7x. Okay, let's take a look at number 9. It says an angle is 10 degrees more than 3 times the measure of its complement. Just find the measure of the complement. Okay, we know that complement means that it has to add up to two angles have to add up to 90 degrees. So we know that formula is 90 minus x. Okay, so it's 90 minus x, and then we're going to go ahead and plug in some things, make an equation. Alright, so we know that it's 3 times more than the complement. So we have x equals 3 times the measure of its complement, which is 90 minus x. We also know that the angle is 10 degrees more than 3 times the complement, so we're going to add 10 back at the end. Okay, so we're going to go ahead and solve for x. Okay, so 3 times 90 gives us 270, and 3 times minus x gives us minus 3x. Okay, and we're going to set all that equal to x. Alright, so we want to go ahead and get everything on the same side, so we're going to add 3x to both sides, and if you do that, that gives you 4x equals, and then we're going to combine 270 and 10, and that gives you 280. And then we're going to divide each side by 4, and that gives you 70. Okay, and to find the complement, remember you had to have it be, add 2 angles that add up to 90, so you have 90 minus 70 equals 20 degrees. Okay, so all of that work to find the measure of the complement. Okay, so this one might take a little bit of work. Go ahead and look at it a little bit more, work it a few times if you have to, and then move on. Number 11 talks about vertical angles. What a vertical angle is when you have, let's say, the angle LMK, this guy right here. The vertical angle would be the one that's directly across from it. Okay, and when you have those vertical angles, you know that the angle measure is going to be the same for both of those guys. So the angle of LMK would be equivalent to JMH, for example. The same thing would be true for HML and JMK. Okay, so those would also be vertical angles. Okay, so that's just one thing to remember. Alright, example 12. It says, light passing through a fiber optic cable reflects off the walls of the cable in such a way that angle 1 is congruent to angle 2, and angle 1 and angle 3 are complementary, and angle 2 and angle 4 are complementary. If angle measure 1 equals 47 degrees, it wants you to find all the other ones. Alright, this problem isn't so bad, we just have to know our different rules for complementary. Okay, so it says angle 1 is congruent to angle 2, so that we know if measure angle 1 equals 47 degrees, then we know that angle measure 2 is also going to be 47. Okay? And then it says angle 1 and angle 3 are complementary. So we know that angle 1 plus angle 3 has to equal 90. So we'll do 90 minus 47, and that's going to equal 53. So we know that one is going to be angle 3. So all we have left is angle 4. We know that 1 and 3 are complementary, and angle 2 and 4 are complementary. Okay, so since measure angle 2 is equal to measure angle 1, we know that all of those are going to be complementary to measure angle 4. So measure angle 4 is also going to be 53 degrees. So angle 4 is also equal to 53 degrees. Okay, so it's just going to take some practice knowing what complementary, supplementary mean and applying those concepts. Okay, number 13 says, suppose measure angle 3 equals 27.6 degrees. Find measure 1, measure angle 2, and measure angle 4. Okay, so it said that angle 1 is congruent to angle 2. Alright, we want to find all these angles. Up top it says that measure angle 1 and measure angle 3 are complementary. So let's go ahead and take our 90 and subtract 27.6, and we're going to get 62.4, and that's going to be our measure angle 1. And since up here it said that angle 1 and angle 2 are congruent, we also know that that's going to be measure angle 2. Our last piece of information that we need is measure angle 4. And since we know that measure angle 2 and angle 4 are complementary, since we have 62.4 as measure angle 2, all we need to find is the complement of that, which of course is just going to be 27.6 degrees. So measure angle 4 is going to be 27.6 degrees. Okay, so number 14, I want you to go ahead and look at the previous page of the notes. We did one that was pretty much just like this. Okay, so go back, take a look at that one, analyze it a little bit, and then try to apply that information to example number 14.